Okay, PreCalc, we're going to wrap up lesson 5.3 today with these last examples. This first one is showing you what we call a half angle. Notice right here that it's x divided by 2. So we're going to pretty much ignore that until we get to the very end of the problem. So let's go ahead and solve as normal. So we'll subtract 3 over and divide by 3. That'll be equal to -1. Okay, now, so let's just go with when does tangent equal -1? Tangent equals -1 at 3 pi over 4 and at 7 pi over 4. So instead of saying our angle x equals 3 pi over 4 and 7 pi over 4, we're going to say that x over 2 equals 3 pi over 4 and 7 pi over 4. From here, we're going to make two little equations. Now, this problem here just says to solve, so that indicates we're going to be going around the circle infinite times. If I look at these two angles and their positions on the coordinate plane, I'm going to be here and here. So the first thing you notice is that these angles are 180 apart. So actually, I'm not going to need this equation because what I'm going to be doing is adding pi to get there. So I'm going to go ahead and add in pi here. And then what you want to do is you want to solve this equation for x. So I want to get x here by itself. So I'm going to multiply everything by 2. So both sides get multiplied by 2. And if I multiply 3/4 times 2, I get 3/2. And I also have to multiply here by 2. So again, you don't do anything with this divided by 2 business until the very end of the problem, and that's when we multiply the whole answer by 2. Okay, for the next one, it says solve again, so that means we're going to be writing our answers with infinite trips around the circle. This one has been factored for us, so it's ready to go ahead and set the factors equal to 0. All right. Again, we're going to leave the 3x alone, and where is tangent equal to 0? Tangent is equal to 0 when y over x is 0, and that's at 0 and pi. When is tangent equal to 1? That's at pi over 4 and 5 pi over 4. And this is just x. This is 3x. Okay, so let's kind of map these out, see what we have. Let's just stay over here. Pi over 4 and 5 pi over 4 are 180 apart. So to take care of these answers, I will just add 180, so pi n. Over here, 0 and pi are also 180 apart. So I'm going to have 3x equals 0 plus 180. I don't need this one. Notice I didn't need that one now because they're 180 apart. And then I have to take care of getting x here by itself. So at the very end, I'm going to divide the whole thing by 3. So we have this set of answers and this set of answers that complete our solution set. We will be working with more problems like that in lessons 5.4 and 5.5. Moving on. Let's look more at some of these quadratics. And this one, as you'll notice, is already in terms of one trig function. So I don't have to make any substitution. But what I can do is go ahead and factor it. And tangent x equals 2. Tangent x equals -1. So what you're going to be prone to do is you're going to be looking on your unit circle and you're going to try to figure out where y divided by x is equal to 2. And there isn't a place on your unit circle with the angles that you know about. So what we have to do here, tangent can be any number. The domain of tangent is all reals. And so all you're going to do here is say that x equals the arctangent of 2. And we're going to have to add n pi to that. So remember the period for tangent is pi. So we're going to be adding n pi to that to take care of every angle that has a tangent of 2. Okay. And then this one, we do have angles on our unit circle whose tangent is -1. Those angles are 3 pi over 4 and 7 pi over 4. And again, where are they at on your unit circle? They're here and here. And so all I need to do is take 3 pi over 4 and add n pi because they're 180 apart from each other. Okay, this one. So what's happening with this one is if you try to factor it, there aren't factors of 1 that add to 3. So if you look for those, I'm not going to find any. So factoring is just not going to be anything that works on these problems. And when factoring doesn't work, you have to go through with a quadratic formula. So we're going to say tangent of x equals -b plus or minus b squared minus 4ac all over 2a. Okay. So let's just pause there for a minute. So if I take that into my calculator, then I'm going to have tangent of x equals, okay, so -3 plus the square root of 5, and then divided by 2. -0.381966. That's pretty good. And then tangent of x equals, actually, let me move that. Okay, let me find -3 minus the square root of 5, and then divide that by 2. Okay, tangent again can be any value. Its domain is all real. So what we're going to do is we're going to find our angle using the tangent inverse or arctangent feature in our calculator. Okay, notice I kept a whole bunch of decimal places on there. Your other option would be just to leave it as -3 plus radical 5 divided by 2. So second tangent of that decimal, -0.381966, is this decimal here. And they're going to be rounding these to 4 decimal places. I'm going to do the same thing over here. I'm going to do the inverse tangent of -2.618034. And again, make sure your calculator is in radians. Okay. Now what you have to keep in mind is that we're not going to have negative answers. So if I go back, that many radians, I'm back here. What I want to do, so this angle represents negative 0.3649. What I want to do is I want to come around the positive direction. So I'm going to take x and I'm going to add that to 2 pi. 2 times 3.14. And I'm going to get 5.9183. I'm going to circle that. Now you guys know that tangent is negative in this quadrant, as well as, oops, let me draw that a little thinner, as well as this quadrant here. So I have tangent showing up 180 apart. So I have another angle right here that has the same tangent. Well, you guys know about vertical angles from geometry. So this angle is also 0.3649. I can find this angle here by taking pi 180 and subtracting 0.3649. And the answer there is roughly 2.7767. All right, so those are the two answers for that left equation. Now, it does say to solve, but I believe these were on the unit circle. So we're going to go with 0 to 2 pi here. Okay? And I'll add those directions to my next one as well. Okay. For this next part, I'm going to kind of map it out. Okay. Pi over 2 is 1.57. So again, this angle is showing up in my fourth quadrant. So that's negative 1.2059. And the first thing I want to do is I want to make it positive. So I'm going to add 2 pi to that. So 2 pi minus 0.12059. Know that. All right. There's that answer right there. So what I'm going to do next is this angle is the same. It's 1.2059. And I need to come around this way. So I'm going to take pi minus that. All right, 1.9357. There's your 4 answers. I'm going to pause this video and we're going to do a second example like that here with example 13. So hang tight. We'll come back and do another one.